For almost all of human history, we knew about 8 planets. That's it. Just the ones right here in our own backyard. But in the last 30 years or so, basically in a single generation, everything we thought we knew about the universe has been totally flipped on its head by the discovery of planets outside our solar system. And the scale of this change is just staggering. As of late 2025, NASA has confirmed that we found over 6,000 exoplanets. And that number? It's not standing still. It's climbing all the time as we find and confirm more. We've literally gone from 8 planets to thousands, and it feels like it happened overnight. So, after 3 decades of searching, what's the big takeaway? Well, I think Dr. Eric Mamajek from NASA said it best. Star Trek was right. Planets aren't some rare, special thing. They are, as he put it, ubiquitous. They are absolutely everywhere you look. And once you accept that fact, you really have to start grappling with the scale that is just, well, it's almost impossible to wrap your head around. Because if planets are common around the stars we can see, then the total number of worlds out there is truly mind-bending. See, those 6,000 plus confirmed planets, they're just the tip of the iceberg. They're only the ones we've been able to spot so far. But when you take the data from missions like the Kepler Space Telescope and do the math, astronomers now figure there could be 1 trillion or more planets in our Milky Way galaxy alone. Just think about that for a second. That's probably more planets than there are stars. Okay, so how on earth do you find these things? It's not like you can just point a telescope and snap a picture of a planet light years away. It's more like a really clever detective story, a great planet hunt unfolding across the cosmos. And you can really see how our detective skills have evolved over time on this timeline. The very first finds back in the early 90s were super clever. They used the timing of dead stars called pulsars. Then came the radial velocity method, where we looked for the tiny wobble a planet's gravity causes in its star. But the real game changer was the transit method, which we've backed up with other cool techniques like microlensing, and now these incredibly precise measurements from space astrometry. Out of all those methods, the transit method has been the undisputed champ. This is the workhorse behind big missions like Kepler and TESS. It's found thousands of planets by basically watching for a star to blink, that tiny shadow a planet casts when it crosses right in front of its star from our point of view. So here's how it works. First, you need a bit of luck. The planet's orbit has to be perfectly lined up with us. Then, as it passes in front of its star, it blocks a tiny, tiny fraction of the light. We're talking a dip in brightness of maybe 1% or even less. But our instruments are so sensitive now they can spot that dip, and by measuring exactly how much it dips, we can figure out just how big the planet is. Pretty cool, right? So what have all these amazing techniques actually found? Well, it's not a galaxy full of solar systems that look just like ours, that's for sure. Instead, what we've uncovered is this bizarre and wonderful zoo of exotic worlds that totally defy what we expected to find. I mean, get this. We found hot Jupiters, massive gas giants that whip around their stars in just a few days, something we used to think was impossible. We found rocky worlds so close to their sun that their surfaces are literally oceans of molten lava. And we found planets on these wild, stretched-out orbits. Seriously, nature's imagination is just way bigger than ours. But maybe the biggest surprise of all is this. The most common type of planet out there in the galaxy seems to be a kind of planet we don't even have in our solar system. They're called sub-Neptunes, bigger than Earth but smaller than Neptune. And the weirdest part? There isn't a single one here at home. It kind of makes you wonder if our little neighborhood is the weird one, not the other way around. As fascinating as all these weird worlds are, for a lot of people, the real goal of this whole search is to answer that one huge question. Are we alone? And that brings us to the hunt for Goldilocks planets. The very first filter we use in this search is something called the habitable zone. You've probably heard of it as the Goldilocks zone. Not too hot, not too cold, but just right for liquid water to potentially pool on a planet's surface. And as far as we know, that's a key ingredient for life. This chart, wow, it really puts the whole search into perspective, doesn't it? Out of the nearly 6,000 confirmed exoplanets, only that tiny little sliver, just 46, are thought to be rocky planets orbiting inside their star's habitable zone. It is quite literally like looking for a needle in a cosmic haystack. And here's the catch, and it's a big one.
Most of these potentially just right planets, they don't orbit stars like our sun. They orbit small, dim red dwarfs. And the problem with red dwarfs is that they can be incredibly volatile, blasting their nearby planets with massive flares and radiation. It could be a really hostile place to try and get life started.
And that's exactly why the search is now entering a brand new phase. It's not just about finding planets anymore. The next great challenge is to actually study them up close, to scan their skies for the first real signs of life. This means we have to move beyond just finding little dots of light. The next great leap is to analyze the very air on these distant worlds for what we call biosignatures, the chemical fingerprints that could only be left behind by living things.
So what are we looking for exactly? Well, we're trying to sniff out gases like oxygen, ozone, water vapor, and carbon dioxide. Now, finding any one of these alone doesn't prove there's life, but if you find them all together in just the right combination on a rocky world in the habitable zone, well, that would be a monumental, world-changing discovery. And here's the amazing part. The tools to do this are here, right now. The James Webb Space Telescope is already taking the first revolutionary steps in this direction. It and the next generation of telescopes we're designing are being built not just to find planets, but to actually read the air of other worlds. So this is the roadmap. Today, we have the incredible power of JWST doing groundbreaking science. And then looking ahead to around 2040, NASA is planning the Habitable Worlds Observatory, a mission being designed for the specific purpose of taking pictures of Earth-like planets and analyzing their atmospheres for those telltale signs of life. So let's just step back for a second. We've gone from knowing about just one solar system to thinking there are literally trillions of planets in our galaxy. We are the first generation of humans in history to know, for a fact, that we live in a universe jam-packed with other worlds. And all of that leaves us with the ultimate question. With all those places to explore, what will we find next?